Hello, good morning everyone. I hope you all are well and welcome to my presentation. First of all, a warm welcome, sir, on the behalf of MSCCS students. Let me quickly introduce myself. I am Ajay, final year student in Master of Computer Science at Central University of Rajasthan, and I am here today to talk to you about my DIP project. As you can see on the screen, the title of my assignment work is related to the face detection, and I have complete my assignment task under the guidance of Mr. RaviRaj Choudhury, Assistant Professor at Central University of Rajasthan. So today agenda of presentation is I have divided my presentation into three main parts. First, I will begin with an introduction. Secondly, about the approach to solve face detection problem. And finally, about references. So let's start with introduction. Face detection, this is basically the computer vision problem. In face detection, what we do, we basically take any input image or maybe any video footage, and we just try to find out the location of the faces. And then this is also the mandatory part of face recognition process. And face detection, it is very complicated task because it's influences by various factors like complex environment, pose, lighting conditions and angles and all these things. So let's see what are difference between face detection and face recognition. So first I am talking about the face detection. In face detection, basically we just given a particular image, maybe what we have inputs, maybe like footage or maybe some videos. We try to find out the location of the faces where actually face are allocated in the images or videos. But in case of face recognition, we label that faces, means we tells about the who's that guy. Basically here, as you can see, this guy is John Smith, this is age and the gender, and this is the Janidio 26 and female. So let us see some real life application based on face detection and face recognition. So right now in this COVID situation, mask is compulsory for each and every person. So many companies or organizations use face detection technique to detect their employee wearing mask or not. So mask detection basically is the live currently working application based on face detection. Here we don't use the face recognition basically. Now if I talk about face recognition based application, now currently all the phones or security system use face recognition technique for unlocking the phones or intents gate. Okay, basically to solve this problem we can use machine learning, or other option we have deep learning. But in case of deep learning, we not need to specify the specific feature of the face because convolution neural network automatically detect uh, all the feature of the faces at training phase. But in case of machine learning, we need to give the features of the faces basically, and then we train our algorithm to detect faces. So Boyle-Jones algorithm is a state-of-the-art machine learning algorithm developed in 2001 by Boyle and Jones. This is basically used for face detection purpose. This algorithm consists of four things: first hard feature, then integral image, and the ADAPOS technique, and the cascading. But the hard features are nothing which these are the basically the features of our faces which we give to the machine learning algorithm so that it can learn from the faces and then we test our data. This is a sample of her features used in the original research paper published by Boyle and Jones. The first two set of rectangular features are responsible for finding out the edge, maybe it's horizontal or vertically. The second set of three rectangular features are responsible for finding out if there is any lighter region surrounded by the darker region on either side or vice versa. The third set of four rectangular features are responsible for finding out change of pixel intensity across diagonal. So basically this is the features which would be capture certain facial expression like eyebrow and like nose and etc. The this algorithm basically the consist of 1.8 lakhs features. The objective here is find out the sum of all the images pixels lies in the darker area of the hard features and the sum of all the images pixel lie in the lighter area of the fixer hard feature. As you can see here, this is the lighter hard feature, this is the darker hard features. We need to just sum of all pixels these pixels, and that means we say that there is a feature detected if horse value is closer to 1, otherwise if horse value is far from 1 it means features are not detected. This would be a hectic operation even for a high performance machine. To tackle this problem they introduce another concept known as integral image. This is an integral image perform the same operation. Integral image is basically calculating from the original image in such a way that each pixel in this image is nothing but is the sum of the all the pixels lying in its left and the above in the original image. If I try to find out the sum of no not sum if I try to find out the value of this pixel of the integral image, what we can do, so this is the pixel, what I can do, I am sum of all the above and the left pixel, so 1 2 3 4, so here is a 4 is come. Similarly as you can see in the integral image how it's calculate the sum of the pixels, this is the formula for that. As you can see in this is our original image. From original image we try to find out the integral image, and from the integral image we perform the operation. In operation we try to sum the brighter pixel and the darker pixel and try to find out the value of this hard feature. Basically if this is closer to 1 it means or features is detected, otherwise it's not. The features set consists of approximately 1.8 lakh features, as I already told that. The majority of these features would not work well. Basically these are irrelevant, most of are irrelevant to the face features as they will be too random to find out anything. So here they need a feature selection technique to select relevant features from the hog feature set, but also we eliminate the irrelevant ones. They use a boosting technique called data boost in which each of 1.8 lakhs features were applied to the image separately to create weak learner. As you can see these are the weak learner, these are the features basically, and then we find out the output we get. With this technique there I have 1.8 lakhs 1.8 lakhs features. If I apply the If I apply the what feature selection technique, then I got 6000 features only. Now come to the cascade part. The subset of all 6000 features will again run on the training image to detect if there is a facial feature present or not. Now the author will take a standard window size of 2 cross 2 which the feature detect will be running. It's again try some task. To simplify this, the purpose of the another technique is this called attention cascade. The idea behind it is out. Not all the feature need to run on the each image as I saw in the visualization technique. This is so in Boyle Jones research, they had a total 38 stage for something around 6,000 features. The number of features in the first 5 stages 1, then 10, 25, 25, and 50, and these increasing in the subsequent stage. The initial stage will simpler and larger number of features, remove most of the window, not having any facial feature, thereby reducing the false negative rate basically. So this is how the detection of the features take place in stage. You can notice that when the window is at a no face region, only the first stage will be two rectangular features are running, and as they discard the window before the second stage, only one window which actually contain a face run both the stage and detect the faces. So this is our whole code for detection, face detection. This is a sample work I do for testing this algorithm, so you can check out or read the OpenCV algorithm, sorry, OpenCV library which contain the R cascade frontal features. If I talk about the deep learning technique, we not need to give the features externally. Convolutional neural network CNN, which is basically for use for computer vision task, this is automatically detect the features of our face. As you can see here, we only give the initially images and automatically it's detect eye, nose and mouth and other relevant feature. Based on that, it's find out the given input image contain faces or not. So these are the references that I take to make this presentation and also for research report. I mean report. And thank you so much. Have a good day.